In section 5, we look at cloud services and applications across quite a number of domains. This gives an idea of how cloud services are being used in various industries. Right. Let's take, for example, in healthcare. Um, this diagram illustrates how cloud services may be applied to the healthcare scenario. Notice that we have two public and private clouds where we can basically have the electronic health record. The electronic health record consists of quite a number of elements, but the ones that are highlighted in this on this slide are the health information management system, the laboratory information system, and also radiology, and also ones that relate to, of course, patient information systems. Then we also can create public-private cloud, which focuses basically on diagnosis reports. Notice that the electronic health record system, which is cloud-based, is available to the hospital and to pharmacies, and also to other players like governments, health insurance companies, and so on, as well as clinicians. Clinicians in this particular case involve the healthcare provider and also specialists, all of these together. Notice also that the doctor ideally is engages in encounters with patients, and that's when they generate information that goes into the health record. The patient also has access to the hospital, and the information they access from the hospital can be online, and this could be extracted from the cloud. The same with pharmacies who get a prescription and then they update the electronic health records to show that a patient has been given certain medications. Healthcare providers such as insurances, also the patient directly contact these people who eventually need to reflect that in the electronic health record. Notice also the patient has access to laboratory results, diagnostic lab, and who, when they get their results, they send them to the physician. Normally the patient presented the lab for samples to be obtained or for any diagnosis to be done, but the patient doesn't normally get the results. The results are sent to the physician, who can then access, do some diagnosis and submit diagnostic reports. So basically all the information in the electronic health record can be cloud-based, the same as diagnosis reports. So this is only one perspective on which you can view how cloud services can be used in healthcare, but basically this covers the bulk of what you might find. Right now let's look at energy systems. In energy systems, you can have a cloud-based framework for predicting faults in energy systems, because faults are very crucial to energy systems, because any faults could lead to power cuts, which could have disastrous consequences on almost all aspects of life, including people's health. And so it's important to come up with an efficient fault prediction and a general fault reporting system. Normally what you have, such a framework could have data collectors, which saves the data, and You then have false database updates as well that come into the system. You could also have false prediction, which uses false database to basically predict or learn some of these systems. But of course, you always have a cloud-based distributed batch processing that happens, especially when we deal with analytics. But generally, for data is collected from green power generation like wind and solar, and also some power plants. Data is collected, and then of course there is analytics that is done. So this might be how energy systems might utilize the cloud or are already utilizing the cloud. Now let's look at transportation systems. Right, this is an area that probably is emerging, but most companies these days have got their fleets of vehicles, which are now things in the Internet of Things. In other words, these vehicles have been augmented with tracking and sensing devices, which collect information. So the cloud in that case could be used, as we discussed, that Internet of Things goes hand in hand with the cloud. They complement each other, especially when it comes to storage, collecting large amounts of data and storing it. But then you could have real-time vehicle tracking and also vehicle routing, and also alerts for any issues that might arise. So those are based on data that is collected from the vehicles. Of course, the vehicles usually communicate via radio communication or mobile wireless communication as they move around. Now let's look at manufacturing. Manufacturing can use the cloud, both public and private clouds, for data integration, data compression, data archiving, data filtering, data analytics, and also control data. Right, in this diagram you will see two abbreviations: PLC for programmable logic controller and OPC or for open platform communication, which is a standard. Right, you could have a programmable logic controller which gather data from these various, in other words, data can be collected from these programmable logic controllers. And also you have access control monitoring data anyway with cloud based apps that makes use of this data. So in industry, in manufacturing industry, especially in the production line, that's where you find programmable logic controllers, which can also provide data that goes to the cloud. Of course, the communication mechanism would be the open platform communication, which allow connection to these programmable logic controllers. So they are actually on the cloud. Even monitoring or even controlling these machines can be done via the cloud. I'm sure you are familiar with a case where the United States managed to sneak in a virus in the manufacturing devices because they were basically controlled via the internet or via the cloud. Right, cloud services. Now let's look at government. Government is a typical example where you have private and public cloud and a lot of things in between. You may have the central government and the state governments, and also government employees and agencies, and then in other words, government to employee, and also international where you have government to government, and then government to citizens, and government to business. All these, it end up being like a community cloud where you have various government agencies that are basically communicating. So the entire government could be basically cloud-based with segmented portions of the cloud. So the cloud is crucial Even when you create an account in Amazon, they want to distinguish whether you are government or not, mainly because they have instructions to make sure that any government function that makes use of the cloud probably should be put under the government community cloud as well, to save government some money. Right, in education, this of course is where we can have a lot of cloud. For instance, a university could basically use a cloud. A university or school information management systems can also be cloud based. Also, virtual learning and online video lecture repository can also be cloud based. You should note that at Palmerston North we have lectures that can automatically record what goes on in a lecture, and the storage is basically done in the Microsoft Cloud, in our case at Massey, where we use some of these cloud-based systems that are mainly Microsoft-based as well. And also you could have student collaboration online. If you consider, for instance, Stream could be cloud-based. If you imagine how many people are using Stream within Massey, there are hundreds of thousands. Okay, maybe not much hundreds of thousands. We are students close to about more than 20,000 students, all of them accessing and uploading documents and all that stuff. So ideally you want that to be cloud-based in order to exploit that. So education is an important environment. So in the communications industry, you could have you could visualize the radio access network. Right. Notice in this diagram you will see abbreviations BBU, BBU being baseband unit, and then you have RRH, which is remote radio head. So remote radio heads, they are part of the radio access network. Normally you have optical transmission network that is hooked onto the radio network with optic fiber, and then you might have virtual network functions, and also virtual baseband unit clustering, and network function visualization management and extraction. Of course, network function visualization infrastructure might include compute module, network storage, and of course all of them would be visualized. So that could basically function as in other words, the entire network infrastructure is in the cloud, which of course runs on the hardware that will be implemented. So you could visualize the mobile core network. Now an extra abbreviation in this diagram are the MME, mobile management entity, the home subscriber server HSS, and the saving gateway, and then finally the PGW, packet data network gateway. So so you can actually implement the visualized core network as software, and implemented software and deployed in the cloud. Right. So where you have of course a visualized core network as to run the entire system. Right. We have now come to the end of this part 1 of this week's topic. What we have done in this recording is to define what cloud computing is in section 2. Of course, in section 1 we covered, we gave an overview of the course and where we are, and also some of the resources that you require for this course. And then we defined cloud computing, we looked at cloud computing models, platform as a service, infrastructure as a service, and software as a service. We also looked at deployment models for the cloud, which is public-private hybrid cloud models. And finally, we looked at cloud computing applications, where we outlined possible uses of the cloud services in healthcare, in education, in government, energy systems, manufacturing industry, and so on and so on. Right. Notice that towards the end, sometimes I give you questions that allow you to revise the type of questions that are based on that particular topic. Although I label as tutorial exercises, but you could practice on these as part of your exam preparation. And so we come to the end of this part 1 of this week's topic.